Welcome. Let's solve Leetcode 2425, bitwise exclusive OR of all pairings. All right, let's make this bigger so we can read it. All right. All right, so we're given a two zero indexed arrays, nums1 and nums2, consisting of non-negative integers. There exists another array, nums3, which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. Return the bitwise XOR of all integers in nums3. Okay, I think this is pretty straightforward. So let's go over this first example. So nums1 is 2, 1, 3, and nums2 is 10, 2, 5, and 0. And this is the XOR between every element in nums1 and every element in nums2. And the final result is 13. So we have that. And in this case, we have nums1, sorry, for example 2, we have nums1 equals 1, 2, and nums2 is 3 and 4. And the result is 0. Okay, so I just want to point this out here, and this will be a key part to our solution, is that notice that there is an even number of elements in nums1 and an even number of elements in nums2. Okay, so let's get started with our solution. It should be straightforward and not too difficult. Let's make this slightly bigger. Okay, so let's suppose that we have maybe nums1 equals, well, let's just go with that, 1 and 2. And we'll say nums2, we'll just call it nums2 equals, we'll set this to A and B. So it's maybe easier to see. So when we pair everything, so we'd have what? 1, A1, A2, and we also have B1 and B2. So notice how, in essence, we have something like this. We have something, this is the length, so 2 times 2, and this is 4. So a key fact or identity for XORing is something like whenever you have some number, so whatever it is, I'm going to call it I. Whenever you XOR it times with itself, it's equal to 0. So that's a key feature we'll be using for our solution today. So notice here how when we have an even value for both nums1 and nums2, we're always left with an even pairing. So meaning, like, see this A, when we XOR this, because ultimately we're doing something like this, XOR with 1, XOR with A and 2. This is difficult too. Okay, ultimately we end up with something like this, yes. And now order doesn't matter with XOR. We can rearrange the ordering and we get the same result. So meaning that the XOR is commutative. Okay, so so here notice how this A XOR with this A, that's 0. This 1 XOR with this 1 is 0. So, and so on and so forth. So it only makes sense that the final result is 0. And we can do this for any values. For example, if I put C and D here, we'd ultimately end up with what? C XORed with 1, XORed with C, XORed with 2, XORed with D, XORed with 1. And notice again, but obviously we have to combine them, but we still have the same scenario where we still have an even number of pairings for every single element. Hence, the result is 0. Okay, so that should be fair enough. So then, when is the result not 0? So let's see what happens here. So let's make this, what we can do is we can do something like, let's make this really simple. I'm just going to make this simple. I'm just going to put one element for suppose nums1 has an odd number of elements. but just to keep it simple, let's suppose it's just 1. Well, when we have 1 here, then the result is this. We have A XORed with 1. Then we also have to XOR that with B XOR with 1. So let's take note of what we have here. So when nums1 is odd, because nums2 is even, when nums2 is even, we have an even pairing for this value. So notice how 1 XOR with 1, that's even, hence when we XOR all of them together, it'll be 0. And the only thing we're left with is just A and B. So let's try something else now. What if I add maybe a C and a D here? So that means we would have to add more characters. We'd have C XORed with 1, and then XOR with D XOR with 1. So again, we have an even number of pairings for the 1, so that means we get 0 for those. However, let's bring up another note. Whenever we have I XORed with 0, that equals I. So I wanted to make that point. That maybe that should be valuable information as well. So so even though the 1's XOR to 0, what we're left with is this. We're left with A XOR B XOR C, C XOR D. Well, an XOR 0, but as I mentioned, we can remove it. It doesn't add any, adjust the answer. So my point to you is, when nums1 is odd, we'll have the XOR of the elements from nums2. And again, I just use a simple one odd element here. I could have done 2 and 3, but then we'd still have the same situation because we have 4 parents for each of these, and so they would go away, and we're left with these individual elements. Meaning, yeah, we'd only have we'd be left with an odd number of elements for nums2. Meaning something like this. We'd have suppose this was the case. We'd have A XORed with 2, and then A XORed with 3. But we'd have the same for all of them, B, C, and D. And notice how we can pair the ones. Sorry, we can pair the A's so that we're left with 1 left. Hence, whenever we have an odd number, so we'll say this: when we have an odd number of elements for nums1, then we will have an the result. Let me see. Then the result will include the XOR of all elements of nums2. And that's what we have here. I've just shown that. Okay. So now what if they're both odd? So if they're both odd, well, let's see what happens when they're both odd. So again, we can just do a simple example. This easy example would be just 1 and an A here. So when we have that, we just have 1 XOR with A, which leads us to believe that if they're both odd, we would have the XOR of each of them independently, but all together. So let's maybe make that a little bit more realistic. Maybe something like this. If I did this here, B and C, well, this would be 1 XOR A, 1 XOR with B, 1 XOR with C, and then the same thing, I guess. What if let's do this here. Maybe not. And same thing here, we'd have 2 XOR with A, 3 XOR with A. And notice how we'd have an odd numbers of odd like a frequency of 1, and then we also have an odd frequency of A, and same thing for B and C. And so eventually though, this result would have A XOR with B, XOR with C, XOR with 1, XOR with 2, XOR with 3. Okay, so that's about it. I think the code will make it clear if that wasn't clear, and I apologize if it wasn't. So let's kind of get started. So what we'll do is we'll initialize the result equal to 0, and then we'll check the length of these. So if the length of A is odd, and so I'm using this N1 to check if it's odd. If it's odd, then remember we need to use the other values. We'll XOR that with itself. So we'll say for B in B, result XOR equals with B. Okay. Now if B is odd, if length of B and 1, then we do the same thing but for A. So we say for A in A, we can say result XOR equals with A. Then we can just return result. What we'll do here is, let me see something here. Yeah, I think that's fine. Let me just well, let's run the tests that Leetcode provides for us. Okay, looks good. And let's submit it. Okay, very good. Okay, looks pretty good. All right, so that's that. Now let's try implementing the solution using C++. So let's change this here, and maybe let's go back to the description. Okay, so now again, it's going to be the same type of approach. So we'll say, maybe make this smaller here. So we'll set or declare our result. So maybe int result equals 0. And let's just return it right away so we don't forget. So let's check if, well, let's change this name to A. So how do we check if A is odd? The length of A is odd. So if A dot size and 1, then what do? We say, okay, for int B in B, we can XOR the result with every value in B. So result XOR equals B. And that's it for that. Then we do the same exact thing, but for B. Now we check if B is odd, if the length of B is odd. So if B dot size and 1, for int A in A, result XOR equals A. Okay, and now let's submit it or test it locally. I don't know if locally is the correct term. I just know these tests are provided by Leetcode, and we can just run them against what we have submitted or written so far. And now we can actually submit it. Okay, great. One thing though, we could have consolidated this, but I think this is better. I think it's better to do them individually and let the result accumulate. Okay, if you found this video helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself. Cheers.